Welcome everybody. My name is David Stevenson. I'm the product manager for Mako, and I'm joined by two of my colleagues, one of whom is Andy Cardy, who is going to show you how easy it is to code with Mako, and is going to risk everything and write some code live in front of your very eyes. I'll begin by explaining a little bit about who we are. Global Graphics Software is headquartered here in Cambridge in the UK. That is our office in the center of this image, taken by one of our test engineers with his drone earlier this year. I rather like that picture. I think it's a good one. Global Graphics Software is one of a group of companies, also named Global Graphics, that develop integrated software and hardware solutions for graphic and industrial inkjet printing with locations across the globe. And at Global Graphics Software, our principal products are these. Today, obviously, we're focusing on Mako. If you want to learn more about any of these, then please visit our website or get in contact with us. So these are the topics that we're covering today. The third topic gave us the title for this webinar, as it examines the role Mako can play in a universal print workflow. So universal print is a solution that organizations can use to manage their print infrastructure through cloud services from Microsoft. And you'll learn more about it and Mako's potential for modernizing such a workflow when Andy covers that topic. So before we start, a bit of housekeeping. You can enter questions into the Q&A panel during the presentation, and my colleague Cash, who handles Mako's technical support, is going to be monitoring as we proceed. So we'll get back to those at the end. If there are any interesting questions, then we'll try and answer those. I believe that as this is a webinar, you're muted automatically when you join. But if you are able to stay muted, that would be preferable. And just to let you know, we are recording this session, and we will send out a link to all attendees after the meeting, or possibly tomorrow. So, Andy, would you like to introduce yourself, and then we can get started?
Yes, I'm Andy. I'm a principal engineer in Global Graphics in the technical services area, and I'm also a developer advocate for the Mako SDK, hence the awesome Mako t-shirt. So, yeah.
Yes, well, I should be wearing a Mako t-shirt as well, but unfortunately mine didn't arrive on time. Anyway, let's not go there. For the first topic, we're going to talk about consolidation. So one of the challenges of needing to work with multiple page description languages, or PDLs, is that you can find yourself working with several different technologies for processing them, each with their own APIs and licensing models, making maintenance more difficult or adding to the cost. Consolidating around a single technology that can handle multiple PDLs makes sense. Mako is just such a technology. Andy, let's see it in action.
Okay, so hopefully you should all be able to see my Visual Studio editor now. So we'll start off nice and simple. So as David says, one of the ways that we can modernize print workflows is by consolidation. So you may have multiple libraries, which, one library for each PDL that you support. You can use Mako instead to consolidate all of those libraries down into one. And this demo aims to show how we can take all of these test files on the right, so the supported formats for Mako, PCL, PDF, PostScript, PCL XL, and XPS, and using a very simple amount of code, process them using the one Mako library. So all we need to do to get started is create a new JAWS Mako object, just with some defaults, and we'll call that Mako. We also need to put these in using statements just because the C# objects we get here are disposable. Probably good to note that all of these demos will be done in C# just for convenience. But obviously we have many different wrappers around Mako for anything between C++, Python, Java, and C#. Next thing we need to do is enable all of the features, which allows us to use all of the inputs and outputs that Mako supports. And then we can go on and get our files. So we have a test files folder. And let's create a folder called directory for that. And then we will get all of the files that are in there. Okay, and then what we can do is we can enumerate those files. So for each, give me a file. And now we can use Mako to get the, well, actually before that, what we need to do is we need to work out what format we have, because as you see in this folder here, we've got different formats, and Mako needs to know which one we're opening, which makes sense. So we've got a very convenient method here, which given the file extension just allows us to get the Mako supported format. Okay, so let's call get format and we'll call it with file.extension. There we go. And that is our input format. Perfect. So now we've got our input format, we can create a iInput, which is a Mako object, give it a Mako object and the input format. And, oh, I've got an insert on. iInput var input. So this is our Mako object that we need to be able to open our file. So we give it the file.fullname. And this gives us an assembly. So in Mako terms, an assembly is a collection of documents. PDFs only have one document. Other PDLs, such as XPS, can have multiple documents. For this, we'll just get the first document to make this simple. So now we've got the assembly. What we can do is we can take all of these in our PDL agnostic assembly and output them to PDF. So what we need to do now is create a iPDF output. Again, giving it the Mako object. And this is our output. And we can write the assembly. So we just give it our assembly like so. And obviously we need to tell it where to write it to. So what we'll do is we'll say file.name and just put .pdf at the end, because we're taking all of these different file formats and writing them out to PDF. And that is all there is to it. So we're going through this file, looking at all the different files, inputting them into our PDL agnostic DOM, and then we're converting them and outputting them. So if we have a look in our debug folder and give this a whirl, we should see that it will go through all of those files fairly quickly after this is finished building, and it will output them. There we go. So we're taking PCL, well, all of these formats, converted them to PDF. And if we open this up, we can see it's all the same document, but I've just added the original format to it, just so we can remember where it's come from. Same for all of them. How's that, David?
Very good. Yes, I see that. That to me looks very straightforward. Whatever PDL you're working on, you use exactly the same approach. I noticed that along the way you've introduced us to the Mako document object model, or DOM, by showing us a hierarchy of the iJaws Mako class, an assembly and a document. And I also spotted that you use the Mako-based PDF editor, which is a Mako-based viewer.
Oh, yes.
So,
yes, indeed.
Why would we use anything else? Anyway. But the question then is, if we need to change the content in some way before writing it out again, is that going to be any easier with Mako? For example, if we wanted to add a watermark to every page, how would we go about doing that?
Yeah, really simple actually. And because naughty me, haven't used usings. Because, you know, from the assembly onwards, it's all PDL agnostic. It means that you can write this code once and it will perform watermarking on any input format, which is cool. So what we can do is we can get the page content. So we'll get the first document, the first page, and edit it. And that gives us our page content. And then we can add just a small amount of extra code. And what this does is it creates a black color because we want our watermark to be black, and it is translucent. And then we create a brush out of that. So it's a color brush, a solid color brush with our translucent black. And then what we do is, because we're adding some glyphs to the page, we need both the color and the font. We use Mako to find the font on disk. This is the font that we'll want to use. And then we can create our glyphs. So this is a Unicode string that we're using. And then we say we want to use this brush and this font. And then we get our glyphs out. And then the only other thing to do is say on our page, append the child, ooh, not all of that, which is our glyphs. So there you go, a couple of seconds work, if that. So now we're adding watermarking to all of these different file formats. So if I give this a run, we should see that we'll get another nice folder of output. And this time, regardless of the input, we've watermarked it all. So now we've got this watermark string on all of them. How's that?
That's very good. So that floating value there, that 15%, that's your opacity.
Yeah.
And how do we know that the watermark's going to go over the text?
It depends on the order that you add the glyphs to the page.
Okay,
so in this case, append child adds it to the end of the node list for that page.
Right, so it's going to go on the top of the Z order.
Yeah.
Cool. So, so you saw that Mako's document object model, or DOM, is PDL agnostic, meaning you can modify the document in exactly the same way, regardless of the PDL being processed. So the message here is that consolidating to a single technology can save time and money, because you can write the same code and apply it to different PDLs. So we're going to sort of build on that example, moving towards our universal print example, and now we're going to look at layout analysis and redaction. So in the first example, you saw additional content being added to the page in the form of a watermark. What if you want to change content that's already there? So in this exercise, the requirement is to redact personally identifiable information from a PDF. So the first task is to find the text. Andy, how do we do that with Mako?
Okay, so we're going to have a look at this file. So this is a sample statement from the Bank of Mako. The first thing we need to do if we're going to redact this sort of stuff is obviously get the text. And to be able to get the text, the first thing we need to do is analyze the layout. So, I mean, all of these things you would think are really simple. It's like, you know, find the text on the page. Well, that's so simple, surely. But actually, because of how PDF is structured and other PDLs, you have to do a reasonable amount of analysis on this page to work out the reading order and make sense of all of this text. It's not like a flow document like Word, where as you see it, it is laid out and it flows. PDFs are different. They're a fixed format, and you know, the items on the page can be declared in any order. So the first step is to perform some layout analysis. So before we even get to redacting, we have to use Mako, and quite conveniently, we have a page layout analysis tool, and we can give it Mako like so. And then we give it the page content. And this is our page layout. And then what we can do with this page layout is call analyze on it. And what Mako does under the hood is it goes through a series of different steps. They're all defined here, but we'll want to do every single step. because we want a fully analyzed page with a reading order, and we want all of the text to be presented to us in a natural reading order. It is a very hard thing to get right. I mean, you just have to look at other applications, and for example, flyers, which you would naturally read from top to bottom, left to right if you're English, but you know, different flyers actually may be very hard to read because they're declared in different orders, and text up here is declared last and text down here is declared first. So you have to do this layout analysis. And you know, just selecting some of these documents in Acrobat, for example, sometimes they don't get it right, and you'll select your text and you'll see some really weird things, like this bit up here, like right at the top, will be selected if I'm going downwards. So it's a hard thing to get right. Anyway, Mako provides an implementation which hopefully does a really good job. And we can get the text back by saying page layout dot get page as a string. So this is all you have to do to get some coherent text back from a PDF, just a few lines. So let's see if that works. Actually, let's not put a breakpoint in there. Let's just write this out to the console. There we go. So we'll take that input and we'll write all of this out, and we'll see, yeah, this looks like the text, and it looks like it's in pretty much the right order. So if we open up that file again, we'll see that the address, I think, was pretty much at the top. The address, etc., primary account number, bank statement, maybe should be there, but otherwise it reads very well. Hard thing to get perfect. Okay, so that's how you get text, David. Does that make sense?
Very good. Yeah, well, that looks very straightforward. As usual, Mako's doing the heavy lifting. So, what about redacting? Having sort of found the text, have you got to do something complicated with page nodes and looking at the page tree and that type of thing? How do you redact information from the PDF once you've got the text?
Yeah, good question. So thankfully, you don't have to go through the DOM and find all of the text yourself. Again, this is something that Mako will do for you, which is very convenient. Another thing that seems easy, but then when you put, you know, Japanese or Chinese or even Arabic languages into the fray, when you try and find this text, it's actually not an easy thing, especially with Unicode and normalizations and stuff. So what we're going to do is, now we've got the text on the page, we want to find the bits that we want to redact. So to do that, you could pass it off to an AI model and say, you know, AI model, I've got this text on my page. What's the personally identifiable information? And it will give you back the you know, the terms in that text which the AI model thinks is personally identifiable. We'll skip that out for now, and we'll just use this convenient method, which will say, right, out of that text, this is personally identifiable, and this is personally identifiable. And what we'll do is we'll go through and redact all occurrences of these two items. So we've got our two terms to redact now. So what we need to do is we need to enumerate through. So for each terms to redact, let's get our term to redact. And then all we need to do is use Mako's text searching to find out where those occurrences, where those terms are on the page. So the text search needs the page layout because it needs to know, well, this text is in this column and in this paragraph. So when I search for something that spans multiple lines, I know that, you know, the search can go over these two lines. So we use the text search, the page layout, and we get this text search object. And then it's as simple as saying, I want to search for this term. And then we get our hits back. So these are the hits which represent quad points of where the hits are on the page. So 4 points, 1, 2, 3, 4, that's where it is on the page. So now we've got our hits on the page, what we can do is we can enumerate through them. So we need to turn those quad points into a rectangle. And then what we can do is we can use that rectangle to create a redaction annotation. So redaction annotations are part of the PDF specification. Mako obviously supports different annotation types. Redaction is one of them. So we say, right, I want to redact this area because I found the text there, and we want to color it red as well because it stands out, makes sense. And then let's just add it to the page. And that's all it is to it. Automatic redaction using Mako. Cool, eh? So let's give this a run. Okay, so found occurrences of that, and it's finished. So now, if we hop along to the folder, so redaction, bin, debug, blah, and then go to output. So we'll see that nothing is actually redacted, and there's a good reason for that. If you have a look at this in Acrobat, you'll see that it has actually been redacted, because if you go to the comments panel, absolutely no, you can see that these redactions are actually here, but they just haven't been applied yet. So Mako's done the right thing. All we asked it to do was add redaction annotations. And this might actually be kind of useful if you have a review stage. So if you want to automatically find things to redact, but you may want a human just to check a few to make sure that it's doing the right thing. So they could go through and say, yeah, apply this, it's right, apply this. But what if your AI model is 100% fine and you just want to go ahead and apply them? Well, you can do that as well with Mako, and it is ridiculously easy. All it needs is 2 lines of code. And what these are is a redactor transform. And the redactor transform transforms the page. And what this does is it will go through the page and it will see these annotations on the page and it will apply them. So you don't have to go through the DOM and say, oh yes, I've got this rectangle and I need to get the stuff out underneath it and securely get rid of it. It will do all of that for you. And it's good to defer that to your library of choice, because we personally have seen different libraries that have done some really nasty things, like not actually remove the content underneath. So you can be rest assured that this should be a very secure way of getting rid of that data. So now, if we give this a run, we should be able to see that it will redact and apply. So if we go back to here and have a look at this now, there we go, automatically redacted. How's that, David?
That's very good. Yes. So so obviously we created those specific annotation types, a redaction annotation type to identify the area to be redacted, and then we can get Mako to do the hard work. I also noticed that the process found addresses split over 2 lines, which isn't always an easy problem to solve in PDFs because of the way that text is laid out, as you were talking to earlier. So but in all, it's just a very neat way of solving that particular problem. Okay, so having looked at a couple of different ways to process a PDF and to modify it, we're going to bring some of that, what we've learned, together and take a closer look at universal print. So Andy's been taking a close look at universal print. He's kind of our expert on it. So before you get into the implementation with Mako, can you tell us a little bit more about universal print and the scenario for the demo?
Yeah. So one way of modernizing your print infrastructure is to move away from the traditional, which will be on-premise print servers. And that's what universal print aims to do. It's a replacement for your traditional on-premise print server, where you would usually maintain, you would have to maintain it, you have to do operating system upgrades every so often, take it offline where you modify stuff. Anyway, universal print aims to be agnostic from all of that, and it allows you to connect up universal print capable printers directly via a network to universal print to your cloud area. And that's really good. And the thing about Universal Print is, just as Office 365 and Microsoft 365 is accessible via the Graph API, which is a developer REST API, so is Universal Print. So it enables ISVs to create integrations which add value to Universal Print. So where you may have added value as an ISV to a managed print server offering, you can also add value to Universal Print via the Graph APIs in different ways. So what we're going to do is we're going to play the part of an ISV, and this ISV wants to modify print data, the payload data that's coming in from print jobs. So we have a user, they're printing their Word document, and the ISV wants to run some sort of service which will intercept that print document and modify it, and then obviously redirect it on to the physical OEM printer at the end. So in this workflow, we see that the user prints a Word document to the ISV's virtual printer. So this is a printer that's been created via the REST APIs and resides in Universal Print in Azure. This print job makes a notification to the ISV service, and the ISV service can then download the job. Once it's been downloaded, you can modify it in any way you want. The ISV may want to add some watermarks to it, or they may have a system where they say, if this user is printing, well, actually we want to apply some sort of security to the document, or we want to just stop it in flight altogether. So there's lots of options there. The modified job is then uploaded back to the ISV's virtual printer, and then the modified job is redirected. And this redirection goes on to the OEM's printer, which is then printed out. So we'll aim to show this whole workflow, but the demo itself is going to focus on this ISV service. So the code that we're going to write today is going to enable this ISV service to download jobs, modify them using Mako, of course, upload them, and redirect them. And if everything goes well, as it has been up to date, we should be able to see this printer here, which I will show you, printing out our modified document, which should be really cool. Does that make sense, David?
It does. Go to
cool.
it.
Let's do it. So this is the code we got to start off with. It would take a little while if we were to write it from scratch, to be fair. So we're going to start off, and the code that we're going to have basically goes through, it finds the tasks that are waiting on the printer that we have. And if you're interested, this is the virtual printer that the ISV has created. We've called it Mako Virtual Printer. And this is the OEM printer, which is the printer that's sitting on my desktop. So what we're going to do is we're going to be notified of the jobs from this virtual printer and redirect it on after modification to the Samsung printer. So here we have the tasks. So tasks are how you get notified of print jobs. Actually, there's a couple of different ways, and it's probably worth pointing out that for convenience and for ease of demonstration here, we're using tasks which we're polling. But if you're to do a full integration and a full product, you'll probably want to look at Graph API notifications, which is where you get notified when there's a print job, rather than having to poll the server, which obviously is not quite as an efficient thing to do. But for the ease of demo, that's what we're going to do. So when we see a task, that means there's a print job. Once we get the task, we get the printer ID and the job ID of that. Once we get that, we get the job back. And if it's one that we can process, at the moment, all we're going to do is redirect it on to the printer. So let's see how this works in practice. We'll start this up, and we'll see that it's polling. So if I go to my very handy VM here, I'll just check that my printer's connected, which it is. So again, we've got the statement here. So all we'll do is we'll print it to our virtual printer. It was called Mako Virtual Printer in Azure. So if we go back to here, it's this one, but it's actually shared as Mako Printer. So the share name is slightly different, just to be confusing. So let's go ahead and print that. And what we should see is that's sent to the printer and it's redirecting, and I'll stop sharing so my screen becomes bigger, and here is my printer. And I've just heard that click, so we should see that it's gone through that round trip. The user has printed to the virtual printer, our polling has picked that job up, and now it's printing on that physical printer just there. So that is the first stage done after it comes out. Does that make sense, David?
It does, but where's the paper? Oh, there it is.
There we go. Ye of little faith. So there we go. That's the document that we just printed. Not in itself amazing, but it's the first step, isn't it?
It is. So I can see how we can build on that. I see you're printing the statement that we saw in the last example. So could you apply the redaction? Because that could have a lot of applications in secure GDPR sensitive printing scenarios.
Yeah, so we got all that lovely redaction code now. So what we could do is our modification could use this redaction, and therefore we can redact on the fly, which would be really cool. So let's take this comment out and actually do some job modification. So the first thing we need to do is obviously download the document. So we've got a small snippet of code here, and what it does is, if you see these little bits here, and you've used the graph REST APIs before, it's just using the graph REST APIs, the Microsoft graph. So what this is doing is we're getting a stream to the document in the print job, and we're downloading it. And that's literally it for the time being. What we need to do now is modify it. So the next snippet of code that we have, we'll convert it from OpenXPS to XPS. It's probably exciting to say, actually, that it is roadmapped to support OpenXPS soon. We don't support it quite yet, but it is on the roadmap. Am I allowed to say that, David?
You are, yes.
Excellent. Cool. So in the future, this bit will be redundant because we'll have our own native support for OpenXPS. But for now, we convert it to XPS, and then we use the same familiar code to open the document and get the page. And then we can make use of the redaction stuff that we had. So after it's been redacted, we output it as XPS, we convert it back open to OpenXPS again, and then we need one small last snippet of code, which will be, before we redirect, to upload it again. So we've downloaded it from the virtual printer, we've modified it, and we're uploading it again. And this is fairly straightforward. So we get the size, we create a structure which tells Universal Print what to expect. We create a upload session, and then we just upload it. And then after it's been uploaded, we can redirect it. Should we see if this works? I think it shall.
I've got my fingers crossed.
What could go wrong? Right, so now we're polling. So if we have a look back on our convenient VM, and then we print it to Mako printer. There we go, that has been sent. So we'll wait for it to poll again, and when it polls this time, yep, we can see we got the job. We've downloaded, converted, redacted, upload. It's going so fast I can't even keep up with it. Converted it back, uploaded, and it's redirecting. And I can hear something printing. Let's see if it's a redacted form. Ooh, exciting. So it is just churning and churning and churning. I'm sure it's warming some toner up, doing whatever it needs to do. And out it comes.
Printer for the next
yeah.
webinar, Andy.
And
ooh,
look at that.
Cool.
It has automatically redacted all of that. Now, does anyone think that's all staged? Because no, of course not. Just to make sure, what we can do is I'll share my screen again, and let's go back into our VM, and let's create a new Word document, and we'll say, this is my account, number. Let's grab the account number from here. It should be automatically redacted. Okay, so no one can say I'm staging that. Let's have a look, see how that goes. So that's been sent to the printer, and it has just picked it up on our polling, so it should be coming out anytime soon. And what we should see is that it's found that occurrence too, even though it's a completely different document. We've used the page layout analysis and the text searching to find it and automatically redact it. And that flashing light and whirring sound says that it's about to come out right now, right this second. Blimey. It is coming. Yes. There we go.
You have to wait so long, it makes you thirsty, Andy.
Yeah, well, there you go. And lo and behold, it's been redacted as well.
Very nice. So that,
how cool is that?
That is cool, actually, because we've just intervened within the print workflow there. So, you could have multiple clients sending in their print jobs, and Mako can very quickly do the job. The thing that I think impressed me the most was the speed. The processing of the document took absolutely no time at all. So I should also point out that Mako can be used to create WCL compliant Windows printer drivers with the Mako printer platform SDK. So that's a framework for developing a driver where we use Mako as the means for converting a print stream from XPS to PDF. Anyway, enough of that. That brings us to the last sample of the day, and we're going to depart C# and wander into the wonderful world of Java. So Mako 6, which shipped at the beginning of the year, introduced a Java API for Mako. So it joins C# and Python as alternatives to the native C++ API. And we wanted to show it off during this webinar. There are several development environments or IDEs available for Java. The Mako documentation pages at documentation.globalgraphics.com features some getting started guides for Visual Studio Code and also Apache NetBeans. But Andy, just to be different, has chosen IntelliJ IDEA from JetBrains. So Andy, what are you going to show us?
Yeah, so as a little bonus at the end, because Java is a new supported language, we might as well just whack out some Java code and see how it goes. Sorry about putting braces on new lines, but it makes me itch something chronic. I'm not a Java developer, so I'm used to C# and braces on new lines. So apologies for anyone that is a Java developer and this makes them itch. But there we go. So what we're going to do is we'll just write some code to say, take a document and write out a PNG image. Nice and simple. So just as we usually do, we create a new JAWS Mako, and let's call this Mako again. And then we use iJAWS Mako to enable all of the lovely features. And then we can get onto the good stuff. So PDF input, because we're going to use a PDF, and we use Mako.open. And then we need to find where our file is. So I just have a little canned path in there. Excellent. And this gives us our assembly. Ooh, assembly, if I can spell it correctly. There we go. And then we'll get the page content by saying, get me the document, get me the page, and get me the content. There we go. And then with the page content, we need an iJAWS renderer. And this renderer is created again using the Mako object. well, I'll put insert on again. Renderer, JAWS renderer. And then with the JAWS renderer, we can say renderer.render anti-alias, and then let's just render the content. It's nice and simple if you just want anti-alias content, but there's loads of different ways that you can call this. I'm not familiar with IntelliJ, so I don't know how to show the overloads, but I honestly, believe me, there's a ton, such as DPI. What DPI do you want to render it at? What part of the page do you want to render if you just want to render in bands, for example? Lots of different options. But let's just keep it simple for now, and that gives us back a image, which is essentially just a raster. And then with the image, we can say IPNG IDOM PNG image dot encode and Mako dot get factory. Actually, no, we don't need that. I do apologize. Image and then the output. So that will be output stream, create to file, and then we'll just call it out.png. Oh, and we do need a Mako.getFactory in there. And that is all there is to it. And I've let these other ones run, but I'm so impressed about how fast this is in Java that I kind of prefer to debug through it just so you can see how quick it is. So if we go into here, this is where the output will be. Let's debug the main method. And you can step over as quick as you like, and rendering is just instant, more or less. And then when we encode this, we'll see that we have our output, which is all nice and anti-aliased, that 96 DPI by default. And there we go, your Brucey bonus.
Very good. Yes. So so we were talking about this when we were practicing, Andy, and we remarked how close this is to C#. Take your using statements out, and that's pretty much it, isn't it?
Yeah, I mean, the only difference in this code, if it was in C#, would be that I would add some using statements in. Obviously, you know, that's not a Java thing. Otherwise, it would be exactly the same, which is quite nice. So if you know C#, you can use this in Java. If you can write in Java, then it opens up lots of different web server usages. Obviously, you can use C#, you know, in ASP.NET Core and Linux servers and all of that goodness as well. So Java or C#, you're good for the cloud because they're both languages well supported by, say, Azure or AWS. So yeah, all good.
Yeah, and I know we've done some Java projects in the past with Mako, but we've had to write our own JNI interfaces for that, which is very painful, and this takes all that pain away, doesn't it? So, great stuff. Do we have any questions? We've got a little bit of time left.
I guess. Oh, no, there was a question. Excellent.
I can't actually see everything. Right, I'm going to switch back to my screen for the...
So, position watermark. Can watermark be any size, or does it have to be PDF file size? Yeah, so I mean, it can be any size. Those glyphs could have been created at any point size, or if you want to rotate or place it, you can use a render transform in the DOM. So that's very easy to position.
Yeah. So if I could come in there. So there is actually some sample code which is available called Mako Watermarker. And it does all of that, and it does some more sort of context sensitive things. So you can specify an angle for it, and it will automatically scale the watermark to fit within a rectangle that you can specify. And you can change the color and change the text of the watermark and so on. For the purposes of the code demo today, we wanted to keep things as simple as possible. But you know, the world is your oyster in that regard. So, well, I'll let you carry on with the following question, Andy.
Yeah, so there's a few questions there. Position, objects in PDF, what type of objects? So I mean, the DOM supports all PDF types, so paths, glyphs, etc. If I gloss over these questions, I haven't quite answered them correctly. You know, feel free to email or message or however you contact us, and you know, ask us afterwards as well. I'm sure we got our communication details somewhere on the webinar, so that should be fine. Can we append import text to PDF from an external file? Absolutely. It's just a case of creating your glyphs nodes and adding them to the DOM. iRedaction transform, remove information from underneath. Yeah, so that is what it does. Mako will remove the information directly underneath the underneath the rectangle, which specifies the redaction transform specifies. If the content is half overlapping, it will be clever about that, and it will cut it off where it overlaps. If it has to, what it will do is it will render the vector content exactly where it's cut off. So if you remove that redaction annotation, you'll see, say, your glyphs up into that redaction rectangle. So we do try and be clever about that. Transparency flattening, it will be good to know exactly what it is that you're interested in, but we do, I believe, David, you probably know more.
I do. So again, using the transforms, you'll when you start working with Mako, you'll learn more about transforms. But one of the transforms we have is for transparency flattening. Now, in fact, we when you do something very simple, such as converting to one of the PDF ISO standards that we support, such as PDFX4 or PDFX1A actually, then by necessity we have to flatten the transparency, and we do that intelligently by looking at the page, working out where the transparency is, and rendering that to a bitmap of an appropriate resolution, and putting a clipping mask around it so that it fits in with the rest of the page. So the page looks as it did before you did the transparency flattening, but in fact there is no transparency left. And we're also developing in the latest version a more intelligent vector-based flattening as well. So lots of options in Mako for doing that.
Do you want to take the next one as well, David?
Yes. Is it possible to transform an image with a custom ICC profile? Yes, it is. So one of the good things about Mako is it has a built-in CMM, a color management module, and so we fully support ICC profiles. So we can, in fact, pretty much all of the color conversion we do is via an ICC profile. We have some standard ICC profiles, some standard profiles built in to Mako for converting between RGB and CMYK in a linear fashion. But you can also load an ICC profile and use that to convert your image into the color profile of your choice. And we've just added support for device link profiles as well. So this is where you don't use two profiles, but a source and a target, but use a single profile that's got both the source and target curves in it. And we'll be supporting those. Well, in fact, we support them already, and we're improving the support in 6.1, which is the version that we will be launching at the end of this month. What barcode can be used? Any barcode you like, Dan. So we don't actually have a barcode library built into into Mako. Something we've considered, and in fact, one of our other RIP products has got a feature built in. But barcodes are changing all the time, and there are lots of third-party barcode generators that can be used. We can provide sample code. In fact, there is sample code in that is available with the SDK, and that shows how you can create a barcode using some third-party code. You usually get back an image, sometimes vector information, and you can incorporate that onto the page, scale it, do whatever you need to do with it. We haven't limited it to a particular library of barcodes. Basically, you can do what you want to do with it.
Yeah, we've got some sample code for adding QR codes, so that can be used to understand how we create the paths that represent the QR code, and then we use a render transform to position and scale it.
Yeah.
So that could be useful as well.
Yeah.
Okay.
Is there a Mako method to automatically determine the PDL of the input stream rather than caller having to know up front? Well, we did it the easy way. We just looked at the file extension to figure out what it was. But in fact, it is possible. It does depend on what it is you're trying to do. So one of the things we have is the ability to interpret the PJL. So if you've got PJL at the wrapping your content, so let's say you've got some PGL and then it switches into PCL or PCL6 or PCL XL as it's known, or switches into PDF or switches into PostScript, then you can cope with that. We don't I don't think we have a way to sort of sniff the format to kind of figure out what it is, but there's ways of programmatically doing that. For example, the PDFs always start with the same few characters and things like that. So so there's ways and means. Can you tell us more about Mako while developing a printer driver? That's kind of an offline question, but we used to ship within the SDK some XPS Druv Windows drivers, but those were Type 3 drivers that were sort of Windows 7 kind of era. So we've dropped those from the SDK. We do have something called the Mako Printer Platform, which is actually for developing version 4 drivers, and there you can use Mako as one of the filters. In fact, I should have had Andy answer this question because he knows a lot more about this stuff than I do.
Yeah, I did a bit of work on the printer platform myself. So as David says, we have code that will work within V3 and V4 printer drivers. V3 is, if you can use the general rule is, if you can use a V4 driver, do, because it's abstracted away from some of the nitty-gritty, for example, private dev modes, which you really don't want to get involved with if you have to. So V4 if you can. Otherwise, you can still use V3 drivers in Windows 10. It was going to be deprecated, but it is no longer being deprecated for the time being. We can use Mako to add a filter to either of those pipelines, to those V3 or V4 driver pipelines. If you drop us a line, tell us about what you're doing, we may be able to help.
So what about the speed of this process? I don't know which process you're talking about there, so I'm going to skip that particular question. Do I always have to start with an assembly, say if I'm interested in a pure PDF authoring creation app? Well, the answer is yeah. In fact, you don't start necessarily with an assembly. In fact, you do really. You need to have the hierarchy of objects in place, and then you can start to add content to a page. And in fact, we have customers who are doing exactly that. So although we've used Mako in the context of processing existing documents today, you can start with nothing. You can create a PDF, or in fact write it out to any of the supported PDLs. You can create Mako DOM objects, so glyphs, images, vector information, append it to a page, append those pages to a document, append that document to an assembly, then write the assembly out. And so it's possible to do PDF authoring from scratch using Mako. A sub question is any built-in support for OCR? No, we haven't built any we don't have any built-in support for OCR. Interestingly, I did a project recently where a customer had used an OCR engine that generated text and also a JSON file that contained the location of all of the text on the page, and then they wanted to take that information and they want to create that, use that information to turn the text, the scanned text, into text that could be selected. And so we use Mako to generate a text layer over the top of the scanned image, so the text could be selected in something like Adobe Reader or the Mako viewer. So we can integrate with OCR. Yeah, Andy.
Sorry, probably just worth mentioning with the authoring creation side of things, it's probably worth mentioning that we also have streaming output. So if you're creating, say, 100,000 page document, you don't have to, say, append each page into a document and then into the assembly, because that would use a huge amount of RAM. What we have is a streaming output which allows you to write page by page directly to your stream or to disk. So it's very efficient in terms of the RAM that you're using, which is nice. And you can thread it as well. So you can thread your page creation alongside your streaming output. So it makes it quite efficient performance-wise. Sorry.
No, that's a good point. It's a kind of question related to the OCR question. Can Mako identify text if printed as image, or would that require an OCR library? Well, if it was an image, then yes, it would require an OCR library. We wouldn't be able to identify that text. If you needed to, you could get hold of the image on the page, chuck it out to an OCR engine, get back the results, and then deal with them in that way. So that may be a possibility. And then the final question that I'm going to answer, because we're coming up to the end, is can we change a PDF from Simplex to Duplex? Well, that's an interesting question, because is this where where you're talking about the metadata on the PDF that identifies Simplex or Duplex? And the answer is yes, you can. So you've got access to pretty much all of the PDF metadata through some dedicated APIs, and where we don't have something specific, we can get to it through the PDF object API, which allows you to get pretty much anything in a PDF. So the short answer is yes. And we are now at the end. So we've had one final question. I'm afraid, Charlie, we're going to have to answer that question afterwards, because he's asking about how do you develop a mask from a raster image. There would be a way, but anyway, we're going to have to leave it there. So it only leaves me to, let me just share my screen again. So very quickly, we're just going to finish off and get rid of that and share. So today we showed you all of those things. I won't read them out again because we've kind of out of time. So I just want to thank everybody for attending, and you'll be receiving an email in the next day or two with a link to the recording. If you have any questions, then feel free to email myself or Andy. He won't thank me for giving his email address out, but there you go, I've done
That's
it.
fine.
And if you want to have a look at our documentation, then there it is, documentation.globalgraphics.com. And also we have a presence on GitHub. There's more code there. And we even have a hashtag on Stack Overflow, don't we, Andy?
Yes, we do. Hash Mako SDK.
Hash Mako SDK. So there it is. So thank you very much for attending, and we'll see you next time that we do a Mako webinar. I'm sure there's going to be more. So thank you very much.
Brilliant. Thank you.